Good morning, students. In the previous lecture, we have learned about different life cycle models in software engineering. What is an introduction to software engineering, and all those we have discussed. Now, in this module, we will discuss about a software project management. That is, how to manage a project, who is going to manage a project team and software project, and all those will be discussed here. A project manager is a person who takes the lead to manage a software project. So there are some responsibilities for a software project manager to manage a project. A software project manager takes the overall responsibility for steering a project. That is, he first takes up a responsibility to guide the team in performing the activities well. The responsibility of a project manager is large and varied. Most of the managers takes responsibilities for the project proposal writing and project cost estimation, scheduling, project staffing, software process, tailoring, project monitoring, and control software configuration management. Now we can broadly classify the project managers' responsibilities into following categories. First one is the project planning and project monitoring and control. In project planning, it involves estimating several characteristics of a project, that is, how much cost is needed, what type of code to be written. Based upon the different activities, the project manager must estimate depending upon the category. The focus of a project monitoring and control activities is to ensure that the software development proceeds as per the plan. Now, there are some skills which a project manager must have to lead a project, that is cost estimation, which means that the project manager should be able to estimate how much amount of cost or the budget that is required for the estimation of different stages in a project. Risk management. Risk management means that the project manager should be ready in such a way that he should be able to manage any kind of risk that occurs in the project. He must overcome the risks that occurs in any project. So next one is the configuration management. Good communication skills. The project manager should first have a very good communication skills to communicate with the customers or to communicate with the project members. Because with this good communication skill, he must be able to convey the requirement and also the things that are necessary for leading a project to a good software project. Tracking and controlling the progress of the project. The project manager should always track and control the progress of the project. Tracking of a project helps the project manager to understand how far the project has been completed or where the project is lagging behind, and many more. Customer interaction. The project manager should be able to interact with the customer effectively so that he could understand the needs of a customer and solve them accordingly. Managerial presentation, which means that the project manager should be capable enough to to present any of the presentations regarding the projects to the higher authorities. Next one is team building. The project manager should be capable of building a team which helps in running of the smooth project design. Previous experience in managing similar projects. The project manager should have a previous experience in guiding. He must be an experienced one in guiding a software project. Good qualitative judgment. The project manager should be capable enough to judge what is good and what is bad that overcomes in a project. Decision making capabilities. A project manager should be spontaneous enough to take decisions correctly and wisely. So now let us discuss these categories in detail much more. Project planning is undertaken and completed efficiently the way the deployment activities and the project planning contains the following essential activities. The first one is estimation. The project attributes have to be estimated. That is, the first one is cost. How much it is going to cost to develop a software. Duration. How long will it take to develop a software? How much effort, which means how much staff or how many members are required to develop a project. Effectiveness of other planning activities such as scheduling, staffing, are based on the accuracy of these estimations. The next factor is scheduling. After the estimations are made, the schedules for the manpower and other resources have to be developed. Staffing. The staff organization and staffing plans have to be made. Means for which stage of the project, how many members of staff are required should be estimated correctly. Risk management. Risk identification, analysis of abatement, planning have to be done. Any type of risk in the project should be managed by the project manager. Miscellaneous plans. Several other plans such as quality assurance, plan configuration management, etc. have to be done. In the sliding window, the planning technique starting with an initial plan, the project is planned more accurately over number of stages. So now let us see about the sliding window planning. At the start of the project manager has incomplete knowledge about the project management. His information base gradually improves with the project progresses through the different development phase, which means right at the beginning of the project, since he is new to the project, he does not have any idea about or any base knowledge about the project. But gradually, learning from his experiences, he becomes an expert to lead a project or progress different development phases. The complexities of different project activities becomes clear and some of the anticipated risks get resolved and new risks will appear. A project parameters are re-estimated periodically as the understanding grows and also periodically of the project parameters change. As the parameters keeps on changing, we need to modify some policies and also based upon the requirements, periodically changes are occurred in these estimating parameters. So, organization of a software project manager plan, that is SPMP document. In SPMP document, the following factors are to be included. The first one will be introduction, which involves some objectives, major functions of the project, what are the performance issues that are occurred in the project, management and technical constraints. The next one will be the project estimation, where hierarchical data, what hierarchical data is used, what are the estimation techniques that are used, what are the efforts, resources, cost, and the project duration estimates. The third factor is schedule. Here, the work breakdown structure, task network representation, Gantt chart and PERT chart representations are discussed. Project resources, how many people are required, what are the hardware and softwares that are required here, are there any other special resources that are need to be included will be added here. Staff organization, team structure, framing a team for each phase of a project, management reporting. To report about the management or any other issues in the project, we need management reporting. Risk management plan. Here, the risk analysis. What type of risks are occurred in the project? Are the risks be able to solve or any other issue or any other steps to be taken to solve the risk are identified here. Risk identification. Once the risk is analyzed, they identify the risk. They identify the risk and ensure what type of risk it is. Risk estimation. Based upon the identified risk, they estimate how much amount of cost is required to solve the risk or any other steps are to be taken to solve the risk and many more. Risk abatement procedures. Risk abatement procedures include the steps that are taken to avoid risks or steps to be taken that have to be done when we overcome any risks and many more. The next seventh factor is project tracking and control plan, which involves matrices to be traced, tracking plan, and what are the plan to control the risks in a project. The last and the final phase will be the miscellaneous plans, that is process tracking. Each stage of the process is tracked for better performance of a project. Quality assurance plan, configuration management plan, validation and verification. That is, first the project is validated and verified and also tested for any other errors. System testing planning. The next one will be the delivery, installation and maintenance plan. That is, delivery of a project, installation. Once the project is delivered, the project need to be installed for the users use, and next one will be the maintenance plan in which all the feedback and all other issues are discussed. Now let us see for the matrices of project size estimation. The matrices for project size estimation includes the first factor, that is lines of coding. Lines of coding is the simplest among all the matrices that are available to estimate a project size. This metric measures the size of the project by counting the number of sources, which means the length of the code is discussed here in the lines of coding. Larger the length of the code, complex the project it becomes. The shortcomings of lines of coding. LOC gives a numerical value of problem size that can vary widely with the individual coding style. Different programmers lay out their code in different ways. For example, one programmer might write several source instructions on a single line, whereas other may write in large number of lines in detail. Lines of code is a measure of coding activity alone. A good problem size measure should have also consider the total effort that are needed to specify a design code test. Just a coding effort. Lines of coding, however, focuses on coding activity alone. Lines of coding measures the correlate poorly with the quality and efficiency of the code. Larger code does not necessarily imply a better quality or higher efficiency. Once the programmers produce lengthy and complicated code as they do not make effective use of available instruction set. LOC metric penalizes the use of higher level programming languages, code reuses, etc. A paradox is that if a programmer consciously uses several library routines, then the LOC count will be lower. This would show up as a smaller programming size. Thus, if the managers use the LOC count as a measure of the effort put in by the different developers, they would be discouraging the code reuse by the developers, which means that a project manager should never depend upon the lines of code to estimate the developer's capacity or capability. LOC metric measures the lexical complexity of a program and does not address the more important but subtle issues of a logical or structural incomplexities. It is very difficult to accurately estimate the LOC in the final product from the problem specifications. The LOC count can only be accurately completed only after the code has been fully developed. The next one will be the function point metrics. The function point metric is proposed by Albrecht. The conceptual idea behind this functional point metric is that the size of the software product is directly dependent upon the number of different functions or features it supports. A software product supporting many features would certainly be a larger size than the product with less number of features. There are some metric computations in the function point, that is, the size of the software product is measured in the function points or in the units of function points. It is computed using different characteristics of a product that are identified in the requirement specifications. There are some steps that are to be followed to compute this function point. They are computing the unadjusted function point into a heuristic expression, refine the UFP to reflect the actual complexities of the different parameters used in UFP computations, and compute the FP by other refining UFP to account for the specific characteristics of the project that can influence the entire development effect. UFP computation. The unadjusted function points is computed here, and the weighted sum of the 5 characteristics of a project are shown in the following expression. The following formula, that is the number of inputs to the power 4 plus, the number of inputs multiplied by 4 plus the number of outputs multiplied by 5 plus the number of inquiries multiplied by 4 plus the number of files multiplied by 10 plus the number of interfaces multiplied by 10 will give you the UFP value of the computation. There are some number of inputs which are to be given. Each data input by the user is counted. The data inputs should be distinguished from user interface, and these inquiries are counted separately. And it must be noted that the individual data items input by the user are not simply added up to compute the number of inputs, but the group of related inputs are considered as a single input. For example, while entering the data concerning about the employee to the employee payroll software, the data items name, age, address, phone number, etc. are considered as a single input. Number of outputs. Here, the outputs considered refers to the reports printed, or screens or the number of output messages that are received or produced. While computing the number of outputs, the individual data terms within the report are not considered, but a set of related data items is counted as one output. Number of inquiries. The number of inquiries is the number of distinct inactive queries which can be made by the users. These inquiries are user commands which require the specific action by the system. So that's all for today's class.